To talk about whether sets are finite or infinite, the main thing to think about is not how big the things are, how many things are in the set. So when we say infinite set, that means there are infinitely many elements in the set, okay? It has nothing to do with the size of the elements, but just how many there are. And similarly for finite, okay? A finite set will be finitely many elements. Okay, so this video is really just going to be an example. I want you to pause the video, and I want you to come up with an example of an infinite set and a finite set, specifically 2 examples for each. I want you to intentionally define an infinite and finite set, and extensionally define both an infinite and finite set. At the end, you'll either have 2 or 4 separate sets, depending on whether they have the same extension. Because remember that 2 sets are equal if they have the same extension. Really kind of tying 2 sections together right here. So pause the video, do that. I'll write down the instructions. Write down 2 examples of infinite and finite sets. And again, I want one to be intentional and one to be extensional. So you could have done a lot of different things. Again, the main thing is to remember extension means that you're explicitly writing all the numbers. We gave one before, the natural numbers, 1, 2, 3, 4. I think I may have included 0, which is very similar. So this is an infinite extensionally defined set, whereas we could define the same set, extensional defined set. We could define the same set intentionally, right, by writing the list of all the k, such that k is an integer, k greater than or equal to 1. For your extensionally, remember, you list them all. Your intentionally defined set, you describe the set. Okay, so there are infinitely many items. And yes, in this case, they do get infinitely large, but that's not the point. We could have also written down the set of all the numbers between 0 and 1. That would also be infinite. Okay, so finite, and again, sets don't have to be numbers. Sets don't have to be things. We could have this be a finite set. Okay, it doesn't have to be the same set. Again, these are the same sets, but it doesn't have to be the same set. Finite set could be the set containing the shape of this star, and a circle, and a rectangle, and a triangle. That's a totally valid set. It's finite. There are 4 things in it, and that's why it's finite. Infinitely many things in this one, that's why it's infinite. 4 things in this one, that's why it's finite. And again, we could make another one. Let's come up with an intentionally defined set. We could have the set of, let's see. I guess you could have done a lot of things. I don't know. Set of my 4 favorite shapes. And again, this is not a very good, well-defined set, because unless you know my 4 favorite shapes, this doesn't give you very much information, but it's potentially valid. Or it is valid, just not very clear, not a very good example. But hopefully your examples are at least as good as mine. And that's pretty much all we got here. Finite and infinite sets, it doesn't matter how big the things are, just how many things there are. Let me know if you have any questions, and good luck.